For this path analysis example using Lisrel, we're going to use data that's reported in our Reading and Understanding Multivariate Statistics book. This data comes from the diagram is located on page 84, and the correlation matrix is located on page 83. In this case, we don't have raw SPSS data to use, so we can input the correlation matrix to be able to see the path relationships between these variables. And so in order to do this, we have to create a simplest syntax file. And so what I'm going to do is close this path down, window down, and then once you open up Lisrel, you can go to New, File and New, and click on Syntax and OK. And this will give you a blank screen to be able to input the Lisrel syntax. In this case, I've done it ahead of time. So what I'm going to do is open the syntax so we can see the relationship between the syntax and the paths analysis that we want to do. So the first line is the title line, and that's I called it cardiac. And oftentimes what people will do is put a little exclamation point there so that they know it's not part of the syntax, but that it's the title. The next thing we need to write is observe variables. And so we need to put in our variables that we're going to analyze. And what I did was I abbreviated these. And so this represents low morale, symptoms, neurological dysfunction, poor relationships, and diminished socioeconomic status. Now, what's important is that these need to be entered in the order they appear in the correlation matrix. So the next line, before we enter the correlation matrix, we need to type correlation matrix. And I took this directly from the book. So the first line was labeled low morale. The second line was labeled symptoms. The third line in the correlation matrix was neurological dysfunction. The fourth line, poor relationships. And the fifth line, diminished socioeconomic status. And so I entered these variables, this correlation matrix, just like it was in the book. And then I entered these in the order they were inputted or represented in our correlation matrix. Now, one thing the book did not do was it did not put ones in the diagonal. You must put the ones in the diagonal if you copy the correlation matrix from another source. The next line, we write sample size, colon, and then the number. And then this is where we establish our paths. And so in this case, I'm going to open up the path diagram so we can look at that. And so this first set of relationships is the path of symptoms to diminished socioeconomic status and neurological dysfunction to diminished socioeconomic status. So we can see that this path and this path is represented by that first statement. The second path, set of paths, symptoms to low morale and diminished socioeconomic status to low morale, is represented by this statement. So we have low morale to symptoms, and then low morale to diminished SES. So this path and this path are represented by this statement. And then our last statement is the paths from low morale and neurological dysfunction to poor relationships. So we have this path, and then we have this path represented. Now, in this case, Lisrel automatically will put in this covariance, but there are cases where we may have to write a path for that, but by default it's put in there. So as we get into more complex analyses, we'll see that we will have the option of either leaving this or taking this covariance out. The next thing that we can do is we can write options, and these options will allow us to obtain other information that we would not normally get when just running the analysis as it is. So I put in options with a colon, and the SC stands for standardized solution. Although we know that if we go back to the path, we can go to View, Estimations, and we can get the standardized path coefficients that way. But this provides us with the output that gives us the standardized coefficients. And then if we write in EF, that will give us the direct and indirect effects of our independent variables on our dependent variables. Then we write path diagrams, so we get the path diagram output, the graphic, and then end of program. And so we want to save this, so we save it as, I called it cardiac COOR, just because it has the correlation matrix in it. And so I can save that. And then if I close this path, then all I need to do is go here and run it, and you can see that I get my path analysis. Now, these variables, of course, are not in the same order as they are in the book, and so you can move them around if you like, but basically we're going to get the same or similar results as to what we found. And so that's basically how you will run this analysis for this week. Now there's one other thing I want to show you. So I'm going to close this down. I can also have in my group of files, I can also create a text file. And so this is the correlation coefficient, this is the correlation matrix of the variables that we added into our simplest syntax in order to run the analysis. So one of the things I've done is I've created a simplest syntax file that actually, no, that's the wrong one. Let's see. Oh, I think I have to create a new syntax file, and I have it here. This is the syntax for obtaining the correlation coefficient from an external file. And so what I've done is I've created a text file, and I've called it cardiac, and I basically, instead of entering the correlation matrix, I'll get the correlation matrix from an external file, and then I still have the same relationships, except I want to put in EF there because I want the direct and indirect effects. So I can run this. Well, I have to save it, I guess. Cardiac. I'll call it import because I'm going to import the text file and save. And you can see it runs. And so I get the same results. Now let's look at the output. One of the nice things about the output is that it gives you the exact programming that you use. So if you need to ever modify, you can copy and paste it back into the syntax window and modify. So we get the correlation matrix. Of course, we already added that in. And these are our structural equations. So this tells us, for example, the correlation, or the R square, I should say, in terms of how much diminished socioeconomic status and symptoms explain low morale. This equation tells us how much low morale and neurological dysfunction explain poor relationships, R square 0.296, etc. So you can see how these values are reported. This is the standard error for each one of our coefficients. These are the z values. This is highly significant. You can see here p is equal to 0.000. Okay. And then we see the correlation matrix for the independent variables. So this is how symptoms and neurological dysfunction are correlated. And that's represented by that path, the covariance path here. That's represented by this path here. Let's go back to the output. And then this is our goodness of fit statistics. Our root mean square error of approximation is 0.233. So that's not a great fit, and we may be able to do some modification with that in terms of making a better fit. But we'll address those issues later. And then the other thing that I wanted to point out is that now we get the standardized solutions for the correlation, for the paths and the correlations. And most importantly, these are the total effects and the indirect effects for the variables that the paths are representing. And then these are the standardized total and the standardized indirect effects for the paths. And when we report our data, we want to use the standardized coefficients.